Okay, number 11, the heat of solution for calcium chloride. So I'm just going to write down negative 82.8 kilojoules per mole. And that's the heat of solution, which we write as delta H solution. If we dissolve that, we have 8 grams of calcium chloride dissolved in a volume of 250 milliliters, which means that we have 250 grams of water, just as a reminder. And we have T initial, well, I'll put it under the water since it's the water, 22.3 degrees Celsius. And we want to find T final, that's the question mark. Okay, so this over here is saying that we have a solution going on, so we know that we have a heat transfer. We have heat from the reaction of dissolving it is going to equal the heat into the water, and they're going to be an opposite sign, so I'm going to put that as a negative. Heat of the reaction, well, we have to get that from the stoichiometry. The calcium chloride is going to go into water and become calcium 2 plus 2 chloride ions, and it's giving off 82.8 kilojoules. So that's the reaction we're talking about. And it says we use 8 grams of calcium chloride because this is kilojoules per mole. So we have to figure out how many kilojoules 8 grams will give to that water. So 8 grams of calcium chloride, and we have to do the stoichiometry, times 1 mole of calcium chloride for every 110.98 grams of calcium chloride. So now I'm in moles of calcium chloride, and I can go to energy released times 82.8 kilojoules per mole of calcium chloride. And that tells us that we're going to release 82.8, we're going to release 5.97 kilojoules, which we'll say is 5,970 joules, because when we do the heat in the water, MC delta T, we'll need it in joules. Okay, so now we're going to take this, move it over here a little bit. Q of your reaction equals negative Q of the H2O. So 5,970, that's the heat of the reaction, equals the opposite of the mass of the solution, the specific heat of the solution, and the delta T of the solution. Now the specific heat, it's water, so we're going to assume that it's 4.18 joules per gram degree Celsius unless you're told otherwise. The mass of the solution, so remember this equals MC delta T. The mass of the solution has to be the sum of the water and the stuff you put in it. So that's going to be 258 grams. So we can find the change in temperature, and then from that change in temperature, we can figure out the final temperature. Now also remember here, this is exothermic, so that heat is a negative heat. So our temperature is going up. Okay, so if we divide both sides by what we have already here, we have 258 grams and 4.18 joules per gram degree Celsius. We will get 5970 divided by 4.18 divided by 258, and you get 5.53 negative equals negative delta T. So we can get rid of the negatives. So T final minus T initial equals 5.53 degrees Celsius. So T final, since we put in minus 22.3 for this, T final will equal 27.8.